Hello students, welcome to my channel Projector. This is the fourth part of the capacitor. Actually, the three videos already I have made over the capacitor. Today's topic is this is a very important topic, the energy stored in capacitor. Energy stored in capacitor. Actually, dear students, today two topics I have to discuss with you are the energy stored in capacitor and the shared distribution of charge between the two bodies. I mean, it's a common potential we have to talk about. Now, dear students, energy stored in capacitor. This is a very interesting story. I'm going to compare all the kinetic energies or the type of energies you know. In linear motion, kinetic energy is actually half mv square. In rotational motion, kinetic energy is half I omega square, right? In linear motion, kinetic energy is half mv square. In rotational motion, kinetic energy is half I omega square. In the capacitor is what? In the capacitor, E presenting E means E represents here electrical form. The energy stored in electrical form, that is half CV square. Capital V is the electric potential, and the magnetic energy stored is a half Li square. Dear student, capacitor is a what? In my first video on the capacitor, I have talked with you all, I have discussed with you all, and I told that capacitor is not a device. Everything in this universe is a capacitor. Everything has a capacity to store the charge. Every object has a bit of charge in itself. Even human being has so many charges in their body. For example, we are having sodium and potassium, and I think I'm not very sure, I'm not a biologist, but I'm very sure if you are lack of sodium ion in your body, you might have a cardiac arrest, okay? Heart attack was said. So, dear student, this is the energy, this is the kinetic energy half mv square in linear motion. This is rotational kinetic energy, that is half I omega square. This is the electrical energy stored in capacitor, that works out to be half CV square, and this is the magnetic form of energy that works out to be half Li square. Capacitor is a device which stores the energy in electrical form, whereas inductor is a device which stores the energy in magnetic form. You can say that now let's compare the physical significance of all this. Mass, whatever role is played by mass in linear motion, same role is played by moment of inertia and rotational motion. Same role is played by capacitor in electric current or electricity, and same role is played by the inductor in magnetism. You can say that capacitor is an electrical mass in electricity, whereas inductor is a you can say that it is a magnetic mass. M is a mass, inertial mass, and I is a moment of inertia that works like that behaves like a mass in rotational motion. So dear students, there is no need to get confused. Half mv square, this is the formula you are studying since 6th standard. Half I omega square is a rotational kinetic energy. So what I mean to say that all the energies are similarly same kind. So there is no need of confusion. There is no, I'm very sure you are right now you are not going to be confused over these formulas. It was at a glance I was telling that what it is. Now, dear students, our motive is to find out the energy stored in capacitor. Capacitor is a what? It is a device which has a capacity to store the charge. But rather, I'll say that capacitor is a specially devised device, or a specially invented device, or is a technique to store the maximum charge in minimum area. Everything in this universe is a capacitor. Everything has a bit of capacity to store the charge. But what is the important, what is different in capacitor? What is a specialty in capacitor? That it is a device which stores the maximum charge in the minimum area. Now, dear students, we have to find out the energy stored in capacitor. How do you find out? There are the two methods. One is using the graph. Let's first solve with the graphical method. After that, the differential. Obviously, I'll apply the differential and easily we will be able to find out. Now, dear students, in a graphical method, I'm going to apply. Question is that is a question to you all. Which is the parameter which decides that how much charge a particle or a body can be given? What is the parameter which decides that how much charge a body can be given? Now, dear students, if you give a charge Q, if you add charge Q over a body, then Q is proportional to the potential and Q is equal to CV. Obviously, you know that, right? Q is proportional to V. How much charge a body can be given? My question to you all that how much charge a body can be given. What I have said that the very first question I asked you all that what is the parameter, which parameter will decide that how much charge a body can be loaded or how much charge a body can be given. Actually, it is a potential. Electric potential decides that how much charge a body can be given. A body can be charged until its potential becomes 3 into 10 to the power 6 volt. That is called, if you are, as soon as you add the charge, potential increases and ultimately you have loaded so much charge that the potential reached to a level that is 3 into 10 to the power 6 volt. That is called, that body has come to the breakdown. If further charge will be added, the charge will leak into the air. Means you can charge whether it is a conducting, non-conducting, no matters. Really, just I'm telling you, really, whether it is a conducting or non-conducting is immaterial. You are just increasing the charge. In the conducting body is what? What is conducting? If a charge is given to the conducting body, then it will flow. It can flow within the body. And in the non-conducting body, if the charge is given, it will lie down at the same point and you have to penetrate the charge. How will you add the charge to the non-conducting body? You have to penetrate the charge because charge cannot move in the non-conducting body. So, dear students, what I am talking to you, that how much charge can be given to a body? It can be given, the charge can be given to a body until its potential reaches to a level called 3 to 10 to the power 6 volt. That is called the body is in breakdown. If you further give the charge will leak into the air, or you can say that it is electric lightning like. Now, dear students, Q is proportional to V, you know, right? It means if the graph is plotted between Q and V, look here, this is a graph between Q and V. This graph would be the straight line. If the graph is between y and x, you know the area works out to be integral y dx, right? Now, this is R is simply, you know, V is equal to W upon Q, or W is equal to V into Q, right? So, if the graph is between V and Q, right, then the energy stored will be what? Energy is what? Dear students, what I said, W is equal to V into Q. A very important thing I have to discuss with you are that sometimes you are a bit confused that what is the potential. Dear students, the basic concept is, you know, electric field intensity E is equal to F upon Q naught. Electric field intensity is what? How you define? That the force experienced by unit positive test charge, means the nature of electric field intensity is the force actually. In the similar way, when you how you define the electric potential at a point, it is the work done in bringing unit positive test charge at that point. It means the true nature, the very nature of electric potential is the work. In similar way, you can say that the very nature of electric field intensity is the force. Actually, these are the basic concepts. If you know these concepts, then it would make life very easy when you are studying the physics. Now, dear students, what I want to say that the Q is proportional to V. Graph has been plotted between Q and V. Because it is a proportionality, so no doubt it would be a line that is inclined, right? Now, the work done, you can find out the work done will be what? Work done in such a case, if there is a graph between y and x, then area covered gives you the, then area is actually integral y dx, and here the area will give you the work done. Actually, area what? Area between the graph and x-axis. The area covered between the graph and x-axis will give you the work done. Or you can say that work done in giving charge to capacitor is equal to area between graph and x-axis. And what that? Dear students, it is clear that this is a right angle triangle and its area works out to be the half into base into height. Half into base is a B and height is a Q. And that is half Q into B. And you know that work done is stored as electrical energy in the, this is UE, electrical energy stored in the capacitor, half QV. And because you know Q is equal to CV, so another form becomes, if you replace Q by CV, so another form becomes UE is equal to half CV square. Now again Q is equal to CV, so Q is equal to CV, or V is equal to Q upon C. If you replace V by Q upon C, you will get UE is equal to Q square upon 2C. Now, dear students, this is the three form of energy. Formula is simply half CV square or half QV. Now, you can transform this formula into one each other. This is the way I have used here the graphical method to derive that energy stored in the capacitor. Now, dear students, let's move further. The same formula can be derived using differential method. How? Look here. Let the same formula I'm deriving using the differential method. Look here, let charge dq is added to the plate of capacitor at potential V, and little work done is dW. What I have written here, step by step, gradually you are increasing, you are giving charge to the capacitor. Let charge dq is added to a plate of capacitor. At that moment, potential was V. So, in adding the charge dq to one of the plate of capacitor, let the work done is a dW, and dW is equal to V into dq. I just had told you that V is actually W upon Q. Electric potential is a what? Work done in bringing unit positive test charge from infinity to a point within the field. How you define the electric potential? It is the work done in bringing unit positive test charge from infinity to a point within the field. Actually, what happens? What I have told you, that electric potential, the very nature, the true nature of electric potential is the work. Now, dW is equal to V dq. You can integrate. Now you are going to add the charge from 0 to Q. Limit will be 0 to Q. Basic concept is what? You are just integrating the function with respect to Q. So the limits should be added with respect to Q. So it will be W is equal to V is equal to Q upon C. You can write 0 to Q upon C dQ, or W is equal to ds 1 by C out. Q dQ is a Q square by 2. And if you replace the limits, then it is a half Q square over C. Or you can write this is the electrical energy, electrical form of energy stored in capacitor. Now, dear student, if you replace Q by CV, you will get U is equal to half CV square, or many transformation you can do. This is the way to find out the energy stored in the capacitor while using differential method, right? So, by the graphical method and by differential method, we derive the formula for energy stored in the capacitor. Let's move further. I'm just erasing it all. Next topic is next topic is a common potential and redistribution of charges. Common potential and redistribution of charges, right? The topic is a common potential and redistribution of charges. How will you define the common potential and what is the redistribution of charges? Dear student, you must, at the beginning of capacitor, the lectures associated with the capacitor, initially I told you, we have find out the capacitance of a sphere. That this is a sphere having the radii r, then its capacitance would be 4 pi epsilon naught into r. If you want to find out the capacity of the earth, then that works out to be C is equal to 4 pi epsilon naught into r, and r is the radii of the earth. That works out to be 6400 kilometer, right? You can replace and you will get the value, right? Actually, the farad is a very big quantity, very big unit of capacity. Even the earth capacity is not very close to that, right? So always we talk the capacitance in terms of the unit we generally use is a microfarad, picofarad, right? Or microfarad you say. Picofarad and microfarad is the same. Now, dear students, we have to find out what is the common potential and redistribution of charges. Dear student, tonight at the beginning of my lecture, my question, I tossed a question to you all. Question was that which is the very parameter which will decide that how much charge a body can be given. Which parameter decides that how much charge a body can be given? That was my question to you. And the answer was very simple. It is a potential which decides that how much charge a body can be given. A body can be charged until the potential reaches to a level 3 into 10 to the power 6 volt, and that is called to be the breakdown potential. And if further you add the charge would leak into the air. Now, dear student, one thing is a very important that you should remember. Few very important things you should remember are, rather I'll say that please mug up. If you are the student of physics, you should know some basic concepts. You know, in the case of electric current, the real direction of electric current is what? The flow of positive charge. The current flows in the direction of flow of positive charge. It is an international standard that has been supposed that current is flowing, or current is supposed to flow, or the direction we do consider is the direction of current is in the is the direction of flow of positive charge. The direction of electric current is decided by the direction of flow of positive charge, or current flows opposite to the flow of negative charge. Dear student, what I want to say that the direction of electric current, I am discussing I am discussing common potential, but you are student, when you are studying the electricity, some basic concepts you should know that what I have said, that the direction of flow of current is in the direction of flow of positive charge, and the current flows opposite to the flow of negative charge. Or you can say that positive charge flows from higher potential to lower potential, because here the word is a redistribution of charge. That's why I am saying that positive charge used to flow from higher potential to lower potential, whereas negative charge used to flow from lower potential to higher potential. Dear students, what I am going to say, that let the two capacitors are C1 and C2. Let two capacitors are C1 and C2, right? Their potential is V1 and V2, and they have been given the charge Q1 and Q2, right? Before connecting, right? Before connecting. The two capacitors I have supposed, their capacitances are C1 and C2. Actually, you know, capacitance is independent. The capacitance is a particular characteristic of a capacitor. It is independent of charge and potential. There is no matter, there is no means of charge and potential. This is the capacity of the capacitor decides that how much charge can be given to it, right? So, the two capacitors I have considered here, the capacity or the capacitance is the basic characteristic of the capacity is a capacitor. It tells that how much charge it can store in itself. Now, there is no, it does not depends on the charge and potential, like, right? It depends on the C is equal to A epsilon naught upon D. It depends on area of the plate, the distance between the plate, and the dielectric inserted between the plates of capacitor. Now, dear students, what I have considered, that the two independent capacitors which are having the capacity C1, C2, potential V1, V2, and let their charges Q1, Q2. Now they are connected to each other. What happens when they are connected? The charge will be redistributed. I have told you that. Question is that why the charge will be redistributed when they have been connected to each other? Because as soon as they are connected to each other, the potential difference will be established between them, and because of potential difference, positive charge used to flow from higher potential to lower potential, whereas negative charge used to flow from lower potential to higher potential. So, and up to what time that they will there will be redistribution of charge, or you can say that up to what time the charge will flow between them, or charge will be shared between them. The charge will be shared between them until they reach to a same potential, because when the potential difference will become zero, there will be no redistribution of charge. And when potential difference will become zero, when they will attain, both the capacitor will attain the same potential, and as the same potential is said to be the common potential. Dear students, what I was talking about, what I was talking with you are that let the two independent capacitors are C1 and C2, their potential is V1 and V2, and the charges on the two capacitors are Q1 and Q2. It is independent means before connecting, right? Now they are connected to each other, right? if they are connected, then what happens? The charge will be redistributed, right? Charge will flow. Why? Because a potential difference will be established between the two capacitors, and charge will redistribute between the capacitors until both the capacitors come to a same potential, common potential, right? Because when they have common potential, the potential difference will become zero and there will be no redistribution of charge. Now, dear students, let both capacitors are connected to each other. If both are connected to each other, then and common potential is V. Dear student, both are connected to each other and common potential is V. You know Q is equal to CV. So common potential V is equal to total charge divided by total capacitance. Total charge is Q1 plus Q2 and total capacitance is C1 plus C2. Right? There was initially, before connecting, we are having the two independent capacitors which were having the capacitances C1 and C2, potential V1 and V2, and let the charges on two independent capacitors were Q1 and Q2. Now they are connected to each other. As soon as they are connected to each other, a potential difference will be established between them, and the positive charge will flow from higher potential to lower potential, whereas negative charge will flow from lower potential to higher potential, and the flow of charge will remain until both the capacitors come to a common potential, and the common potential is derived we found the common potential in this way, that is total charge divided, because Q is equal to CV, V is equal to Q upon C. Common potential means total charge divided by total capacitance, right? Now, dear student, whether they are connected or not is immaterial. Capacitor remains independent from these factors, right? Capacitor depends on the area of the plate, between the distance of the plate, or the value of dielectric constant of the dielectric that has been inserted between the plates of capacitor. Dear student, as I have told you that as soon as the two capacitors are connected, there will be redistribution of charge because a potential difference is established, and that distribution of charge stops as soon as both the capacitors come to a common potential, and we find out the common potential this way. Now look here. After the redistribution, let the charges on two capacitors are Q1 dash and Q2 dash. This is a charge on two capacitors. Then what is Q1 dash over Q2 dash? Or you can write Q1 dash is equal to C1, Q is equal to CV. C1 the capacity of the first capacitor into potential of common potential, and Q2 dash is equal to C2V. So Q1 dash upon Q2 dash is equal to C1 upon C2, or Q dash is proportional to C, right? How the charges will be distributed? That is proportional to their capacities, means the higher capacity capacitor will adopt more charge, and the lower capacitor which is having the lower capacity will adopt less charge. Now, dear student, we find out that Q dash or Q1 dash over Q2 dash is equal to C1 and C1 upon C2. Now, initial energy stored initial energy stored, U1 is equal to half C1 V1 square plus half C2 V2 square. This is the initial energy stored, right? Final energy stored, what is? U2 is equal to half C1 V square plus half C2 V square, because both have same potential, common potential. Or you can write half C1 plus C2 V square, or half C1 plus C2. V is a what? V is equal to total charge divided by total capacitance and whole square. So writing square both. Now DI student, this is half. Now Q1 is a what? Q1 and Q2 are the initial charge on the two capacitors, and at that time you can write it is Q1 is a C1 V1, Q2 is a C2 V2. Initially Q is equal to CV, the capacity is C1 and potential initially was V1 square, and this will be, okay, you can cancel one of the bracket and you would be left like this. Now dear student, U1 is this much and U2 is this much. Let's find out the difference between initial and final energy. I'm writing here, I'm trying to find out U1 minus U2, right? Initial minus final. What comes? Initial one is a half C1 V1 square plus half C2 V2 square minus U2 is a half, it is C1 plus C2, and this is C1 V1 plus C2 V2 whole square. Dear students, what I am doing, 2C1 plus C2 is a LCM, take as a LCM. Now what is left here? Half I have taken out, C1 plus C2 LCM. So C1 plus C2 undoubtedly will be multiplied by this. So if you multiply with C1, it is C1 square V1 square, plus when you multiply this term with the C1, it is C1 C2 V2 square, and when C2 is multiplied this C1 C2 V1 square, and when C2 is multiplied this is C2 square V2 square. Now minus and whole square of that much, open this bracket, it is minus C1 square V1 square plus C2 V2 square. Before the bracket there is an active, when you will open it is minus C2 square V2 square and then minus 2AB to C1 C2 V1 V2. Now look here, C1 square V1 square will cancel, this will be cancelled, right? You will be left, dear students, C1 C2 V1 square plus C1 C2 V2 square minus 2 C1 C2 V1 V2. Or you can write this term, I am writing here please, del U is equal to half C1 plus C2, and here C1 C2 I have taken common. So the remaining part here in the bracket will be V1 square plus V2 square plus V1 minus V2 square. So it is a V1 minus V2 whole square. Now look here, initial minus final. It is a positive quantity, C1 C2 is a positive. V1 minus V, whether V1 is less than V2 or greater than V2, no matter, here is a square, so it is a positive quantity. So whole term is a positive quantity, means UI, initial value, initial energy is greater than final energy. It means as soon as the two capacitors are connected with each other, initially their total energy, their sum of electrical energy stored was bigger than after the redistribution of charges, the part of energy, their total energy stored decreases. The total energy stored in both the capacitor, the sum of total energy stored in both the capacitor decreases. So where does it go? Actually, the two capacitors, how you connect the two capacitors? Through the wire. So there is a energy flow through the wire, there is a flow of charge through the wire. So the energy is lost, right? Because the charge is flowing. How the charge is redistributed between the plates of capacitor? Because charge flows through the connecting wire between the two capacitors, and that is why there will be loss of energy when the charge flow from one capacitor to other capacitor. And this, because of this loss of flow, this loss of energy in the form of heat energy, without touching the wire, how can you tell that current is flowing through a particular wire? If you bring the thermometer close to that place, right, close to, in the neighborhood of the wire in which current is flowing, at that point temperature would be bit higher than other place, than away, than at a point away from the wire, right? So when the charge flows from one capacitor to other capacitor through the connecting wire, the energy is lost in form of the heat, and that is why energy has decreased. So energy is lost, and you have ultimately you prove, because we find out the difference between initial and final energy, that works out to be positive. It means initial energy is greater than the final energy. It means initially the energy stored in the two capacitor was greater than the final energy stored in the two capacitors. Then where goes that energy that has been lost? Actually, that energy lost in form of heat when the heat is flowing through the connecting wire between the two plates of capacitor. Dear students, I tried my best to let you understand the two topics that I have discussed. Next video undoubtedly would be the problem based on the capacitor, different kind of combinations. I'll discuss one by one, because in one of the videos so many things cannot be discussed. I tried my best, and I hope you all would be following my videos. If you think that my video is beneficial to you, then please and please like, share and subscribe my videos, and must put the bell icon so that you must be notified about my new videos. Thank you. Good night to you all.